4, 3, 2, 1. Hello, welcome to the final session of the Security Dev Room. Let's welcome Peter, who will talk about syslog NG. Thank you.
Thank you. First, a few words about me. And sorry for those who were there yesterday in my talk. The first few slides will sound quite familiar. I'm Peter Canik from Hungary, community manager at Belabit, syslog NG's upstream developer. I'm working on packaging, supporting syslog NG. First of all, what is logging? It's recording of events on a computer, for example, an SSH login message under var log messages in a file. You can see here, syslog NG itself is an enhanced logging daemon with a strong focus on high-performance central log collection. Why central logging? First of all, it's ease of use. One place to check for your log messages instead of many. It's also availability. So even if the sender machine is down, you can read the logs at the central location. And last but not least, it's also security, as the first thing in hacking a machine is to remove traces of what you have done. But if you have central logging, then all of the traces are forwarded in real time to a central location where you can check it, what happened to the machine. There are four main roles of syslog NG. First of all, it's collecting messages. It also can process log messages, filter them, and at the end either store them locally or forward somewhere. The main role, the first role is data collection, and I say data and not log collection, as syslog NG can collect practically any kind of data, system messages, application logs together, and they can provide quite useful contextual data for either side. It can collect messages from a wide variety of platform-specific sources like devlog or journal or sunstreams, as many different platforms are supported. As a central log collector, it knows both legacy and the new syslog protocol and can use UDP, TCP, TLS in many cases. It can also collect logs or any kind of data from applications through files, sockets, pipes, and if the application is started by syslog NG, then even application output. The next, and in my opinion, the most important role, at least in a security environment, is log processing. With using syslog NG, you can classify, normalize, and structure log messages. I will talk about these later. You can even rewrite log messages, and you don't have to think about falsifying messages here. But for example, in many cases, you need to anonymize log messages due to compliance requirements. Messages can also be reformatted using templates. When log analysis software needs a specific format, like a specific date format, or have logs in JSON format, and so on. And you can also enrich data using GeoIP or adding fields based on the message content. The next role is filtering. It has two main uses. First of all, discarding surplus logs like debug level messages, or the other one is message routing. So you can make sure that the right messages reach the right destinations. For example, you only send authentication-related messages to a SIEM system. There are many possibilities for filtering. It can be based on message content or parameters, using comparisons, wildcards, and many different filtering functions. And best of all, any of these can be combined using Boolean operators. At the end, you can either store your messages locally or forward to many different destinations. Here comes a tricky question. For those who don't check my slides right now, I mean on a phone or so, which syslog-ng is the which syslog-ng version is the most used? Do you have any idea? Project started a long time ago. Red Hat has version 3.5. The latest stable version, oh, it's actually 3.9. What do you think? Which is the most used version? Any guesses?
2 something.
You were the closest, as it's version 1.6. As there are over 100 million Kindle ebook readers, and all of those run syslog-ng for log collection. Now, back to more serious topics. Bit about message formats. If you take a look under varlog messages, you will see that most of the messages have the date, hostname, and some kind of text at the end. The text part is an English sentence with some variable parts in it. It's quite easy to be to read by a human, but if you have a busy server with 1,000 messages a second, it's quite difficult to deal with it, as you cannot, you don't have the time, and the machine cannot really understand it. There is a solution for this problem. It's called structured logging. In this case, events are represented as name-value pairs. Back to my favorite example, SSH login example, that you can describe the event as application SSH, the user root, and the IP address. The good news is that syslog-ng has name-value pairs inside right from the beginning. Facility, priority, and so on are all saved as name-value pairs. So this is the way how you could use them in filters or in templates. And there are parsers in syslog-ng which can turn unstructured and some structured data into name-value pairs as well. Let's talk about these. The first one is the JSON parser. If you couldn't parse JSON with syslog-ng, then you can see inside the message, just simply store the whole JSON message somewhere. But as syslog-ng can parse JSON messages, you can use the values inside the JSON message for filtering, for reformatting, for other destinations. So the data is much more valuable this way. CSV parser can parse columnar data into fields. The most popular example is Apache access log. In this configuration snippet, you can see the column numbers, and if you take a look here at the bottom of the screen, you will see that the username is used in a file name template. So each user has its own log file in this case. The key value parser was added just recently to syslog-ng, and it can parse key equals something like data. The most popular example for this is firewall logs. For example, IP tables, but this one is from Zorp, another firewall. The most interesting parser in syslog-ng is pattern.db, which can extract information from unstructured messages into name value pairs. It can also add status fields based on the message content and do some message classification like logcheck does. The downside of this parser is that it needs an XML database describing the log messages, so it can only parse messages for which you have a description. Back to my favorite SSH example. Here are a few fields. The first line has some data which is directly extracted from the log message, the application name, the username, source IP, but based on the message content, you can also add that the action of the log was a login and the status was a failure. And based on this, you can state that you can classify this log message as a violation. syslog-ng can enrich log messages and create additional name value pairs based on the message content. I already mentioned pattern.db on the previous slide. You can also use a GeoIP parser to add geolocation based on IP addresses. For example, a country name or longitude, latitude information. It can be used in security as well to detect anomalies, as it's not a real-world situation that someone logs in from Europe and from Australia at the same time. And you can also use it to display locations on a map. Recently, we added another parser which can add metadata from CSV files to log messages. For example, add the host role or contact person, which can considerably speed up log analysis and also helps to create more accurate alerts or dashboards. Next, I would like to talk a few words about configuring syslog-ng. My first advice is don't panic. As I often get the feedback that syslog-ng configuration is very difficult. Yes, it looks difficult at first and sometimes even at second sight, but once you take a deeper look at it, you will see that it's simple and logical. It follows a pipeline model where you have many different building blocks like sources, destinations, filters, and so on. And all of these can be connected into a pipeline using log statements. Syslog-ng configuration always starts with a version number, where it was for which version it was created, and some global options. Most of these can be overridden later in the configuration. You can define sources, and here, as you can see here, this is a single source definition, but it combines two different sources, internal messages, so those generated by syslog-ng itself, and system is for platform-specific log sources. This helps to hide away platform-specific differences, so you can use the same configuration on Linux, FreeBSD, Solaris, and it will find the log sources. The other one is a network source, in this case UDP. Here are a few destinations, the typical var log messages. It's a flat file. The other one is more interesting. It's an Elasticsearch destination where you specify the index name, the type of the message, cluster name, and here you can see that it's using JSON formatting and selecting the different fields what to forward. Oops. Here you can see some filter definitions and loading a database for pattern DB parsing. And here is the heart of the configuration, the log statements, where the upper one is for var log messages, local sources, related filter, and the destination. The other one is more interesting with multiple sources, filtering, pattern DB, and sending the results to Elasticsearch. And here is a nice dashboard from Elasticsearch. It's a word map where the log source was IP tables, and the attack sources are visualized on screen. Here is the configuration how you can do this. First of all, you need a key value parser to extract the different fields from the message. In this case, the source IP. For the source IP, the geolocation is looked up. As Kibana needs a specific format for it, it's rewritten to that format. And here in the log statement, all of these building blocks are combined. PEG is a software in heavy development. It was formerly known as ELSA. It's web application for security analysts, and it's built on syslog and pattern DB message parsing. The results are sent to Elasticsearch, and it has its own web interface. It's not Kibana. In this case, there are some nice graphs coming from an intrusion detection system. In a few words, what are new in syslog 3.8? It has disk-based buffering, a new parser which is easier to use. You can also write parsers in Rust. It has support for all of the latest Elasticsearch versions and many performance improvements. Finally, a summary what syslog can help in with security logs. First of all, it's high performance and reliable log collection. You can parse and enrich log messages, so you can do basic log analysis inside syslog, and you can also efficiently forward log messages to other log analysis tools. If you want to know more about syslog, our central hub of information is syslog.org, or our source code is on GitHub, where we also have an issue tracking system. And if you need help, we have a mailing list, or for near real-time help, we have IRC or GitHub channels. Do you have any questions?
Thank you, Peter. We have an applause. We have 5 minutes for questions, so raise your hand if you want to ask a question. We have the first one here.
Hi. What about support for Docker containers or other containers? So instead of having Logstash or FluentD, getting the container logs put into this and then enriching the log format with container relevant information. Is that supported yet?
Yes. We have a Docker image, and I just checked it and was quite surprised, as the development version of the Docker image had just a few hundred downloads, but the regular image had over 100,000 downloads. So people are using it in Docker.
Sorry, I wasn't referring about running syslog ng inside a container, but rather on a host or a VM where you have syslog ng and it has the Docker daemon or it has Rocket or whatever, and you're running, say, 10 containers and you'd like the logs from those containers to go back to the host-based syslog ng to enrich, to then send them on to some other location. So in order to do that, it would be useful for it to get some information from, say, Docker daemon to understand the name of the container and some other attributes.
As far as I don't use Docker myself, but as far as I know, Docker is logging in JSON format, and that we can process that. I know that it's used, but personally, I don't have much experience with it.
Okay, there's one more question here. Raise your hand if you want to ask a question.
Hello. So my question, it gets more into, like, I suppose, the legal aspects, which I saw mentioned at the start of the talk in your brief. I suppose, like, are there ways which syslog ng can support, like, compliance to, like, EU data protection law for not storing, like, IP addresses or storing them in particular ways which better support, like, some, like, I suppose, minimal standards in what should be captured and not captured?
What we can do is using pattern DB or using regular expressions, you can find IP addresses or credit card numbers in log messages. Both have advantages and disadvantages, and you can either replace with a static text the IP address, or you can use hashes, and if you use a hash of the original, then you can use it in further analysis of the message. So you can follow sessions, what the given user did, even if you don't know the name of the user, but you can follow where is it coming from, what it did.
And we have one more here. It's also fine to just have a comment or reflection or criticism or discussion.
So most of the new assistants are running journald. What is your recommendation? Where is the work split between journald and syslog ng?
Journald is for local log messages. Of course, you can pull log messages from it periodically, but it's still not something for central log collection. With syslog ng, you can constantly, syslog ng can read log messages from the journal and forward it to a central location in real time. So it's better suited for security purposes, I think.
Thank you. Final question? No. Okay, let's thank Peter. And thanks for coming here. This was the final presentation for the day. Thank you.